Hi everyone, today we have lesson 8-3, Factors of Counting Numbers. For this lesson, you're going to want a scratched piece of paper and a pencil or a whiteboard and marker, as well as your math journal. And we're going to go ahead and get started with some equations, multiplication equations, and you need to figure out the missing factor. So I'm going to turn the page, and here we go. All right, so for our first one, we have 2 times what equals 10. Hopefully you had 5. And then 18 equals what times 9? Correct answer would be 2. 3 times what number equals 30? Correct answer, 10. And then 8 times what equals 56? And hopefully you remember that one. It is 7. So today we're going to be talking a little bit about factors. And so I want to review that these numbers that I'm circling right here are the answer to the multiplication problem. That's what we call a product. The factors are these numbers, the numbers that we're multiplying together to get that product. So the factors of 10 here would be 2 and 5. The factors of 18 would be 2 and 9. The factors of 30 would be 3 and 10. And the factors of 56 would be 7 and 8. We'll dig a little bit deeper in that as far as but this is as far as we're going to go right now. For the next problem, you're going to need scratch paper. Here we go. Joanna packs 16 bottles of juice into cartons. How could she pack the bottles so that each carton has an equal number of bottles with none left over? Show your thinking using pictures or arrays. Then write a number model for each of your representations. So what I want to remind you is that when we are talking about using pictures, that means we're going to use certain kind of symbols. Maybe showing the cartons as rectangles and then maybe the bottles of juice as like a circle or something. If we're doing arrays, remember that's rows and columns. And we know that we have 16 bottles of juice and they're going to go into cartons. And we want to pack the bottles so that each carton has an equal number of bottles. So that means that one carton has to have the same amount as another carton. And remember, we cannot have any leftovers. We're also going to do a number model for each of our representations. So I would like you to give this your best shot on your own, and then we will get back together. So go ahead, push pause, work on this problem for a little bit, and push play when you're ready to talk about it further. All right, I got some things set up for you while you were working, and we're going to go ahead and get started. So if she has 16 bottles of juice and she wants to put them into cartons, one thing that she could do is she could just have one carton and she could put all 16 bottles of juice in there. So I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the factors right here, the number model we have here, we have one group of 16. And we know 1 times 16 equals 16. Over here with the blue cartons, we have 2 cartons. And if we had 2 cartons, we could put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 2 times 8 for a total of 16. My next one, I know I can do it into 4 containers. So if I do it into 4 containers, I'm going to put 4 bottles of juice in each of those cartons. And so my multiplication number model for this one would be 4 times 4 equals 16. For this next one over here, I could do 8 cartons, and if I did 8 cartons, I would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And right here, I have 8 groups, and I have 2 cartons, or 2 juices in each of those cartons for a total of 16. Another option that I didn't put on here because I didn't really think it was a very good use of cartons was I could have 16 cartons with 1 bottle of juice in each carton. So what we're going to talk about next is factor pairs. So I'm going to go ahead and go to another slide and we're going to talk about factor pairs. So here we go. All right, I took a screenshot of our work, but I kind of made it a little bit smaller so that we could kind of talk about it and add some notation here. So I'm going to be working with the black, actually a purple pen right now, and I will try to draw arrows so that we can kind of make things happen here. This is the first one that we did, and for this one we had 1 carton and we had 16 bottles in that carton. So for this one, the ways of making 16, the factors we used were 1 and 16. When you multiply those 2 factors together, you get 16 as your product. The next one we did was this one over here with the blue cartons. And when we multiplied numbers together there, we had 2 cartons and we had 8 bottles of juice in each of those cartons. So the 2 factors in that one would be 2 and 8. If we look at the next one that we did, that was this green one, and we would say that we had 4 cartons with 4 bottles in each. So that would be the factors of 4 and 4 are the factor pairs in that one. And then in this last one that we have here, we have another, we had 8 cartons with 2 in each carton. So we're going to have an 8 and a 2. Now you might notice, Mrs. Denowden, you forgot that one that you said about 16 cartons and 1 in each carton. So I'll put that right here. It's 16 cartons and 1 bottle in each carton. But now we're going to look at 16 as our number, and we're going to make a list of all the different factors. So the way that we started with, we're going to focus on that one first. So we had a factor of 1 and we had a factor of 16. So that one takes care of that. And that means we can also kind of not worry about this anymore because we already have those numbers in our list of factors. Another one that we have, and we have it 2 times, we have this 2 and 8 here. We have it twice. So we're going to put a comma, and we'll put the 2 right there, and then we're going to put the 8 right over here. So that takes care of those factors. And then we have one more factor pair, but when you look at that, you notice that we have 4 and 4. You only need to put 4 in there one time. And I know that that kind of feels weird, but because 4 and 4, it's a multiplication square, equals 16. So we would say that these are all of the factors of 16. And 1 and 16 go together, 2 and 8 go together, and then 4 and 4 go together. Let's try doing the carton problem of with juice with 10 bottles of juice this time. So I'm going to flip to that one. How could you pack 10 bottles of juice into cartons so that each carton has an equal number of bottles with none left over? So we just did the same problem, but we did it with 16 bottles. Now we're going to do it with 10 bottles of juice into cartons so that each carton has an equal number of bottles with none left over. Go ahead and push pause while you work on this problem and then play when you're ready to check your work. All right, I got us kind of set up again. So here we go. We are going to first focus on the the red container there that we see, and we know that could have one container and we could put all 10 bottles in there. So the factors for that one would be 1 and 10. The next one, we could have 2 cartons. If we did 2 cartons, we would put 5 bottles of juice in each carton. So we would say 2 and 5 would be the factors there. And then for the next one, we could have 5 cartons. And if we had 5 cartons, then we would have 2 bottles of juice in each of those 5 cartons. So that's 5 and a 2. And this last one, if we had 10 cartons, we would put 1 bottle of juice in each carton. So our factors would be 10 and 1. So when we're talking about the factors of 10, we want to look and see what factor pairs we have. We have a 1 and a 10. We also have a 10 and a 1. So we're just going to do a 1 and a 10, and we just took care of those. For the next factor pairs, we have a 2 and a 5. We also have a 5 and a 2. So we're going to say the 2 and the 5 and the 10. So our factors of 10 would be 1, 2, 5, and 10. So we know, we can think to ourselves, okay, I know 1 times something equals 10. Oh yeah, 1 times 10. I know there's 2 times something that equals 10. Oh yeah, 2 times 5. And that can really help us as we're learning our multiplication facts. Oh my goodness, what happened here? We're going to go ahead and open up our math journal right now, and we're going to open to page 259. You're going to need to have a pencil, and we're going to work through this page together. So for the first problem, it says for each problem, fill in the blanks with a different factor pair that makes the number sentences true. So our first product is 8. And so we have to think of what are 2 different ways that we can get 8. And so the easiest one that I can think of is 1 times 8. All right, can you think of another way to get 8 that doesn't use a 1 or an 8? If you were thinking 2 times 4, you're correct. All right. The next one, to get 18. Let's think here. Oh, I know. 2 times 9. I think that was one of our warm-up problems today. And another one. This one might be a little bit trickier. It has a factor of 3, and I'm going to let you guys come up with the other one. 3 times what equals 18? All right, 27. This one is a little bit tricky, so I'm going to give you a hint. 9 times something. I went backwards. Sorry about that. 9 times something, and then the other one is going to be 1. It is being so silly on me today. Sorry about that. 1 times 27. Okay. All right, for 36, we know that there's a multiplication square that goes there. So we're going to do 6 times 6 equals 36. And then the one that people often forget, it is a 9. A 9 times something. So I want you to try and figure that one out. All right. And then we have 45. When we're counting by 5s, I often think, oh, it's going to be a 5 times something. So 5 times something equals 45. And then another one that I can think of is 1 times 45. There's also another one that I could think of, and it involves a 3. So you can go ahead and try that one if you want to. All right, the Kim family is serving dinner for 24 people. Mrs. Kim could have one table with 24 people, or 2 tables with 12 people each? What are some other ways Mrs. Kim could seat 24 people in equal groups in different numbers of tables? Think about the factor pairs for 24. So what you can do here is kind of like what we did with the cartons and putting the bottles of juice in the cartons. So we know she could already have, we already know this, she could have one giant table with 24 people. We also know that she could have 2 smaller tables with 12 people. So I'm looking for what are some other ways. Ways is going to mean, hint, hint, more than one way. So let's think of 2 different ways down here. So maybe put way 1 in here and way 2 in here that she could arrange her 24 people. So you want to think about factor pairs. What are 2 other ways that we can multiply together to get 24? So what times what is going to get us 24? Those are factor pairs. Okay, and we already know 1 times 24, and we already know 2 times 12. So try to think of 2 different ways. I want you guys to try that one on your own. You can draw me some pictures there, kind of like what we did with the cartons problem. All right, let's look down below. At the bottom, we have 200 equals, and these are problems like what we just did yesterday. So I will do a couple with you. So let's see here. 200 equals, we could do 5 times, and then when I'm looking at this, I would think, okay, so 20 here. So 5 times what is going to get me to 20? 5 times 4 is going to get me to 20. So I want to get to 200. So 5 times 40 gets me to 200. And then let's think about, I'm going to give you this right here. 8 times what equals 72? And then you have to think, I have to get to 720. So 8 times something right there. And then the next one, 200. Think about getting maybe to 20 again, or you can't use the same one. Does everyone see that? See how this is the same kind of problem? You can't use that for either one of them. But I think for this next one, the 720, you have to think about, are there any other ways that we can get to 72? No, there aren't. So for down here, you would want to put 720 and then put a 1 in that other space. All right, good luck on that next one. I can't put the thing in there because that spot is covered on my paper. My apologies. All right, let's go on to our next page, which is 260. And this is a math boxes page. I will walk you through the whole thing, and you are expected to do all the problems today. The first one talks about measuring the line segment to the nearest 1/4 inch. If you still have that ruler, you can use that, or you might have a ruler at your house. And then you have to draw a line segment that is 1 inch shorter than the segment above, and you would draw that in this space. Over here we have some extended multiplication facts. So if we know 8 times 2 equals what, then we can figure out 80 times 2 equals, and then put the product in there. Same thing down here, 9 times 3, we know that product. That can help us figure out 9 times 30. All right, and then in here we're putting in missing numbers on the number line. And when they're talking about missing numbers, they're actually talking about fractions. So go ahead and put those fractions in there. And then over here, we're going to talk about 2 different fractions. 2 different fractions that name the shaded area of both rectangles. So I want you to try to think, when you look at this picture, what do you see right away? And then when you look at this picture, what do you see for that one too? These would be equivalent fractions. So they are the same, they look exactly the same, but can you think of maybe 2 different names for it? And then number 5, partition the rectangle below into 1/6. Shade it a different way to show the fractions that you wrote in problem 4. So I'm going to kind of walk you through this one because I think this one, it's trying to make it more difficult than it really is. So I'm going to partition it into 6 pieces, and then I just have to shade it, not in that way, not in this way, but in a different way. So when I'm doing it, I'm going to shade in blue real quick so you can see it better. Shade this one, and this one, and this one. Done. That's it. It's still the same fraction as up above. So that's all there is to that one. Let's go over your home link. All right, it says use facts, counters, or drawings to help you solve the problems. I really recommend the drawings. I think that they're helpful. The 3rd grade class is putting on a play. They have 18 chairs for the audience. Jayla and Kevin are in charge of arranging the chairs in equal rows with no chairs left over. It says describe the ways that Jayla and Kevin can arrange the chairs. So it says ways here, and we know that ways means more than one way. And then it talks right here about factor pairs for 18. So I would like you to think about maybe 2 ways. Maybe you can think of more ways. I definitely was able to come up with 1, 2, 3, 4 different ways that they could arrange the chairs. But if you can at least come up with 2, that would be great. And then it says, how does knowing ways to arrange 18 chairs in equal rows help you find the factors of 18? So how does that help you? And I want you to think about arranging chairs in an array. There's a certain number of rows and columns and those kinds of things. And then right here, we're practicing with different ways to get 40. Do not put the same factors on both of those. And then over here with 72. What are 2 different ways to get the answer of 72? And honestly, guys, sometimes your only option is 1 times the number, but don't make that like your first one that you're going to go to. And then down below, here's another one, and it's more of like an extended fact. But if you think about it this way, like how can you make 15 and then add that 0 to the end? So give it your best shot, and I think you're going to do great. See you later.